Welcome everyone to Lesson 5, Applications of Volume. So far in the previous lesson and previous lessons before that, we've learned about perimeter area. We did a formula, we worked with a formula called Pythagorean theorem, which dealt with right angle triangles and solving for unknown side lengths of those right angle triangles. And last lesson we did volume. So we are on to some applications of volume. And one of the critical pieces to this, which I'm excited to go through, is the problem solving process. So as we're solving these problems here, it really is important that we're properly interpreting the problem itself uh, and following kind of a problem solving model, a step by step model that you can either write down or you can kind of go through in your mind. It's always better to write it down though. Um, so going through this problem solving process that I have on this first page will be extremely beneficial as we answer these questions, and I think you'll see that when we start them. All right. So number one, before we get to any sort of problems and some real life applications, let's look at this problem solving model. Number one is you want to attempt to understand the problem, right? That's step one. You have to interpret what's going on in the problem. And I wrote down some ways to help you interpret. One of them being, the first one, write out what is given in the question. So it's always a great idea to start things off by writing down what's given in the question. All right. Secondly, write what you need to find to solve in the question. So that's usually going to be given away in the last sentence of your problem. That's usually in math problems, usually that's where you will find, in the last sentence, that's where you'll find what you actually need to solve for. All right, so far you got to write down what you know, write down what you don't know. Draw a diagram. Okay, if a diagram isn't given to you, it's always a good idea to draw a diagram. Okay, so draw pictures and try to make sense of it through pictures as well, visually. If possible, can you reword the question in your mind to simplify it? That's always a good idea to help you understand. Okay, and then lastly, estimate what you think the answer could be. So estimating what you believe the answer could be is an important step. All right, because in the end, at the very end, we're going to reflect on our answer. So once we do come up with an answer, we're going to reflect on it and we're going to compare it to our estimation. All right, and you may have no clue what your estimate might be, but do your best to just try to ballpark it, even if you have absolutely no clue. All right. Second step, you have to begin to develop a plan to solve the problem. All right. And so there's some really good tips here. So work backwards. So we're going to do this. We're going to work backwards when I do my problems when I'm trying to develop the plan of how to solve it. Ask yourself, what items do you need to solve along the way to solve the problem? So obviously work backwards to do this. Then this is a critical step. Write out the formulas needed to solve the items. Okay, so write out the formulas, because once you see the formula, you'll know what you need to find and what you have. And then decide what order to solve all your items in. Okay, fantastic so far. So we're going to reference this when we do the problems. Number 3, actually solve the problem. So act out your plan. Okay, so follow your plan to solve all your unknown items. Change or update the plan if you realize it wasn't correct as you work. All right, so the plan's now written in stone. You, of course, can go back and change it if you feel like what you're doing may not be correct. Last step, review your solution. Ask yourself, does the answer make sense with your estimate? If your solution doesn't seem possible, review your calculations for any simple mathematical errors. So you may get an answer that seems totally off, right? It just doesn't make sense. If that's the case, it might just be a simple calculation error that you made punching numbers into your calculator. So double check your calculations, right? Double check that you're using the proper formula. Double check your calculations. If your solution still doesn't seem possible, then you may need to change your plan again accordingly, okay? All right, let's begin with a word problem, and we're going to reference this here, and we're also going to reference the formula sheet because we're going to need some formulas here, okay? So we'll do that in a second. All right, so a soccer ball is packaged in a cube-shaped box, okay? That's usually the packaging that a soccer ball comes in. And let's remove which is closest to the volume and just replace those words with determine the volume of the space that is not occupied by the ball. So I just want to change that question. So it's determine the volume of the space that is not occupied by the ball. Okay, so let's go to our problem solving model. Step one here is understand the problem. Write out what's given. Write out what you need to find. Okay, so let's start there. So, given. I've got my radius of the ball. Okay. And I have my length, width, and height of the cube. So overall I have that the radius equals 10 centimeters. Okay, that's for my ball. And my cube, I have length equals 20, width equals 20, and height equals 20 centimeters, that is. All right, so that's what's given. Now, what do I need to find? It says determine the volume of space that is not occupied by the ball. Okay, so what I need to find then, okay, is the empty space around the ball. Okay, so see how that right away gives me some clarity. All right, so I really encourage you to follow these steps. Okay, I don't need to draw a diagram. I already have a diagram there. Let's see what else is in my problem solving model. Reword the question in your mind to simplify it, or estimate what you think the answer could be. All right, well, I don't think we need to reword it. We've already kind of done that. We need to find the empty space around the ball in the cube. Okay, let's come up with an estimate. All right, let's just ballpark it. I'm just gonna, don't worry if you're not even close, but let's just think about this. We've got a ball that's 10 centimeters radius, and then a cube that's 20 by 20 by 20. Well, I'm going to say that, first off, the volume of the cube, 20 by 20 by 20, right, is 8,000. All right, so I'm going to say that the empty space is going to be much smaller than 8,000, right? Because I know that the volume of the cube is going to be 20 times 20 times 20. And that's going to end up being 8,000 centimeters cubed. I'm going to say that the empty space is going to be way less than that because the ball has to be in there. I'd say the empty space is going to be, I don't know, let's say 1,000 centimeters cubed. All right, so this is going to be my estimate. You don't have to do this, but I'm trying to give you some direction in terms of problem solving. All right. Now, step two is to develop the plan. So here was step one. Step two, so develop the plan. Well, I know that to find the empty space, this is where you need to work backwards. To find the empty space, I have to find or take the volume of the cube and subtract the volume of the ball. So essentially, take the volume of the cube and subtract the space that the ball takes up, which is the volume of the ball. All right? So my plan is solve, right? What do I need to find? I need to find the volume of the cube and the volume of the ball. That's going to be my plan, and then I'm going to sub into my equation above. Substitute into equation above. All right, does that make sense, right? So I'm going to find volume of the cube, volume of the ball, subtract them to give me the empty space that's left, and then I'm just going to plug those numbers into here and here, and that is going to give me the empty space. All right, so let's execute this plan. Okay, so step 3, the volume of my cube is going to be length times width times height, or just side length cubed because they're all the same. All right, so I've got 20 times 20 times 20, which is 8,000 centimeters cubed. Then I've got my volume of the ball. By the way, when I write V and then ball is subscript. It's like very small in the corner of the capital V, okay? So volume of a ball, I need to figure out what shape my ball is. Well, I know it's a sphere, so go to your formula sheet now and find the volume formula for a sphere. And what you'll find is that it's 4 times pi times radius cubed divided by 3. All right, so pause the video and just make sure that you can find that formula on your formula sheet. Okay, well, I know that R was given to me, right? It was the radius of the ball. Remember, it was 10 centimeters. Okay, so I write that down, and that's all I need to plug in here. I already know what pi is, so let's go 4 times pi, which is 3.14, times 10 cubed divided by 3. Okay, now follow BEDMAS. You have to do 10 cubed first. So I'm gonna do. Don't be lazy here. Write out this step of finding what 10 cubed is first, and that's 1,000. Okay. Now I can sub this all into my calculator. And what do I get? Well, it's 4 times 3.14 times 1,000. Press equals on your calculator and then divide by 3. And you end up getting 4,187 centimeters cubed. Notice I didn't round to any decimal places. Why didn't I round to any decimal places? Well, look at the question itself. Do you see any decimal places in the question itself? No. Did they ask for me to round my answer to any decimal places? No. In which case, just follow what's given in the question. Since there's no decimal places in any of the numbers, go with no decimal places here. Okay, now let's actually solve empty space, right? So the empty space equals, remember, it's the volume of the cube minus volume of the ball, which is 8,000 minus 4,187, okay, which is 3,813 centimeters cubed. There's your final answer. So let's review our estimate, right? Because the last step is always, ask yourself, did what I do make sense? Does my answer make sense? My estimate was that I'd have about 1,000 centimeters cubed left over. I have actually about 4,000 centimeters cubed left over, which means that the ball is only taking up about half the space of the cube. That's fine. I mean that's reasonable that it's taking up about half the space of the cube. So I would be okay with that. Don't overthink it. If your estimate isn't that close, that's okay. Just realize that it's just a guess, right? It's just to kind of your estimate is just to kind of give you a basis of what to go from, right? But it's not going to be that close at the end of the day, unless you're really good at estimating. All right. So let's move on to the second question. A gumball machine sits on a base. The machine has a diameter of 25 centimeters. If each gumball has a radius of 2 centimeters, how many gumballs can fit inside the sphere? Okay. So I have to figure out how many gumballs will fit inside of here. All right. Well, a gumball, I am told, so let's write down what's given. Step 1. Right? My radius of the gumball is 2 centimeters. So I'll just write radius and then subscript G for gumball. And my radius for, sorry about that, my radius for the machine, so R subscript M, is 25 centimeters. Okay, and I'm just going to draw a little diagram of a gumball inside here. Okay, so let's call that 2 centimeter radius. This one has a 25 centimeter radius. Okay, so what do I need to find? Okay, number of gumballs in the sphere. Number of gumballs in the sphere. Okay? I've already drawn a picture. Let's come up with an estimate. Let's try to think of something here that makes sense of how many I think will fit inside. Well, if this has a radius of 2 centimeters as opposed to 25, 25 is 12 and a half times bigger than 2. So this is going to be a little bit tricky. I'm going to just guess. I'm just going to come up with a guess that I think this is going to roughly be 500 gumballs. Okay, I have no clue how close that is. I'm just going to guess that maybe about 500. Just looking at my picture, really. Just looking at the diagram that I drew. Okay, step 2 is let's come up with a plan, right? And work backwards. So I need to find the number of gumballs in the sphere. What would be the formula to find the number of gumballs? This is the tricky part, right? We're working backwards. What would be the formula to find the number of gumballs? Well, it's going to be, you're going to take the volume of the machine and you want to find out how many times bigger the volume of the machine is than the gumball. And so what you do there is you divide the volume of the machine divided by the volume of one gumball. All right? So basically you're finding how many gumballs fit into the machine. That's what dividing means, right? Like if I said, what is 10 divided by 5? What I really mean is, how many times does 5 go into 10? Right? When I say 10 divided by 5, I mean how many times does 5 go into 10? And I know that the answer there is 2. Well, what I'm finding here is how many gumballs will go into the machine, right? So it's the same thing. It's division. It's division. How many gumballs will go into the machine? Okay? So my plan then is solve VM and VG. Once I have those, substitute into formula above. Okay, so substitute into that formula there. All right, so pretty straightforward. Once you figure out that you need to divide, right? And remember, you need to figure out how many gumballs fit into the machine, right? Just like if I said, what's 10 divided by 5? You would say, how many times does 5 go into 10, right? So it's the same thing. So let's do this. Let's figure this out. Let's go to step 3. Okay, so let's find the volume of the machine. Well, from the previous question, we know that the formula for a sphere is 4 pi r cubed divided by 3. Well, my radius, remember, was given to me. It was 25 centimeters for the machine. So 4 times 3.14 times 25 to the power of 3 divided by 3. Remember to follow BEDMAS, so do exponents first. Okay. Ooh, 1 second. Just realized something. Be careful here. Let's read the question slowly again. That they didn't give me the radius. They actually gave me the diameter. So all of this is 25. All right, so my bad here. So the radius is not 25 here. It's actually 25 divided by 2 because the radius is half the size. So my radius is actually, let me just erase. It's actually 12.5. That's my radius. Okay, be careful there. You can see how easily you can make that mistake. Read the question slowly. Okay, so do your exponents first. Do 12.5 to the power of 3. Then multiply by 3.14 times 4. Press the equal sign. Divide by 3. And you will get 8,177. And let's leave it at that with no decimal places. All right? And that's centimeters cubed, right? Okay, now let's find the volume of the gumball. Still the same formula, 4 pi r cubed divided by 3. We assume the gumball is also a sphere. The radius this time was given to us as 2. So do 4 times 3.14 times 2 cubed divided by 3. And remember that cubed just means multiply by itself 3 times. So you're going to do 2 times 2 times 2. Okay, which ends up being 8. So what you get there, once you plug that into your calculator, rounded to the nearest whole, is 34 centimeters cubed. Now let's find number of gumballs. Remember, plug them into your formula of the volume of the machine divided by the volume of a single gumball. All right, so volume of machine is 8,177 divided by 34. I'm running a little bit low on space here, so I'm just going to put my equal sign to the side over there. And it looks like you will fit approximately 244 gumballs. All right. My guess, remember my estimate was 500. Fairly close enough. I was about halfway. If I cut my answer in half, I would have gotten it just about bang on, but, close enough. All right, so I'm going to skip over the question here because I really want to get to one of your homework questions, okay, and discuss this. And I won't fully answer it, but I'll at least get steps 1 and 2 done for us. All right, so I won't actually solve it, but I'll plan it out. So I'll do steps 1 and 2 from the problem solving model. All right, so let's see what this says here. How much more expensive should the large aquarium be than the small aquarium if the cost is based on the volume? Okay, so if the cost is based on the volume, how much more should the large aquarium be than the small ones? All right, so we're going to get to what we need to solve for in a second. Okay, first let's write down what's given. All right, what's given? Well, we've got my length. Okay, so my length, and this is of my, I'll put L subscript S for small aquarium. So my length of the small aquarium, let's say, is 16. My width of the small aquarium is 8. And my height of the small aquarium is 12. All right, so that's given to me. And also, I am given this information here. So my length of the large aquarium is 32 centimeters. My width of the large aquarium is 16 centimeters. And my height of the large aquarium is 24 centimeters. All right, so that's what's given to me. So obviously, looking at that, hopefully you're already realizing that you can find the volume because you know the length, width, and height. So I can find the volume of both. So let's now analyze, what do I need to find? So I need to understand the question here. So let's take a look again. How much more expensive should the large aquarium be than the small aquarium if the cost is based on the volume? So once again here, if I were to reword this, all right, I would say that we need to find out how many times larger the large aquarium is than the small aquarium. In other words, how many small aquariums will fit into the large aquarium? How many small aquariums will fit into the large aquarium? That's what we need to find. That is what we need to find. So, number of small aquariums that fit into the large aquarium. Well, from the previous question, it's exactly the same. How are we going to find that, right? Again, when you want to find out how many times a smaller number goes into a larger one, it's going to be division, right? Once again, I'll use the example that if I asked you what 10 divided by 5 was, right? What I'm saying there is, how many times does 5 go into 10? Well, what I'm saying in this question is, how many small aquariums will fit into the large aquarium? Therefore, what you are going to find, okay, is equal to the volume of the large aquarium divided by the volume of the small aquarium. So if I can find each of those volumes and then divide the large by the small, I'll find out how many times bigger the large one is than the small one. All right? So I'm not going to find the volume there and answer this question, but I've set it up for you. Okay, and this is one of your homework questions. So I've set it up for you where you just have to find the volumes. Okay? I can't stress enough how important it is that you follow this problem-solving model. All right? So make your estimate. And actually, we didn't do an estimate here. Let's do an estimate. Just looking at the picture, how many small aquariums do you think will fit into the large one? I'm going to go with 4. Okay, I think 4. So I'm going to estimate just from the image. So I'll find a place here to put my estimate. Okay, so here's my estimate. I believe that there will be, that the large aquarium will be 4 times larger than the small aquarium. Four times larger. Now, you don't have to write this out, right? Like when you're answering questions, you don't have to write this out, but you should be thinking about it in your head, right? And if you're the type of person like me where you like to write things out because you feel more organized and you feel like you can get your thoughts organized a little better, then write it out. Take the time to write it out. So the large aquarium will be 4 times larger than the smaller aquarium. Therefore, the large aquarium should be 4 times more expensive, right? Because the question is, how many times more expensive do you think it will be if it's based on the volume? So it will be 4 times larger than the smaller aquarium, therefore 4 times more expensive. That's my guess. Okay, so that's my estimate, but go ahead and actually solve what that will be. Okay, and that concludes this lesson. If at any time you want to go back and try the questions that I did, you've got the video to support you. Just pause the video, cover my answers, and try the question for yourself, and then compare with my answers to make sure that you did it right. Don't forget to reference your formula sheet. You will need your formula sheet from lesson 1 to find the volume of all of these shapes. Okay, so that concludes lesson 5. Only one more lesson.